Hello guys, so today we are going to learn about the processes in Linux, and as we read earlier that everything in Linux is a file or a process. In the last tutorial we read about the files and we saw that how Linux stores all of its files. So in this video we are going to learn about the processes. So what is a process basically? So a basic definition of process says that it is a set of instructions written in a file. So let me show you. Let me show you one simple program where I have a test folder and I create a program pit.sh. So when I execute this program that we have done earlier as well, so what it did is it just executed the set of instructions which were given to it and finally gave us the output. But what if I want to see this process when it was actually running? So to see that we will have to modify the code a bit, and here we will put a sleep of 30 seconds so that it may stay in the memory when it was running. So it may stay on in the memory and we can see it. So let me run it again. So now you can see this is executing, and in the second terminal I will do sudo psox dir.sh. So now you can see that this process is there in memory and it is being executed using the shell bash, and the program name is .t.sh. Now once this program gets over, if now again I will search for the same program, you can see that it is now not visible. So this is the definition of process, that says a running program set of instructions written in a file. So what we have seen is when we ran t.sh, when it was running on the system actually, then it is a process. But once it has done its execution, now if I say what is t.sh, then we will say that it is a program containing set of instructions, and when it is running on the system then it becomes a process. So here we can see that it is a process which was started with a Linux geek, and then it got this process ID and so on. So we will learn about these things. What are these fields in the ps output a little bit later. So let us move further on this. So whenever we run a process, there are several states in which that process may go. So below is the diagram in which we have explained the several states in which a process can be. So the first thing is whenever we create a program and we run it using ./t.sh as we did here in the terminal, then when we did ./t.sh, what we did is we created new program and gave it to our CPU to execute. So it is in ready state. When the CPU got time to execute our program, so this was the first thing. Then when CPU about time to execute our program. It is called as running state, and it may happen that your program is too long to execute in one go of a CPU cycle. So in that case, or there may be another case that your program needs some IO, like you need some input from the user. So in that case, when CPU is waiting, or when your program needs some input and needs to wait for the user, then it is waiting, and finally when the user gives the input, then it again goes to the ready state, and from there, when CPU is again ready with CPU is again ready to give its one of its, what you can say, time to this process, that will again come to running state, and finally when the output is displayed and everything is done, then the process goes to the terminate state. So when the process is done with executing all these statements in your program, it goes to terminated state. So these are all the states in which a program goes. So now let us see some practical around it. So so what we did earlier was we created a program, and we saw that there was a program t.sh which was echoing hello, and then it was going for sleep for 30 minutes. So what we will do here is we will run this program, and parallelly what we will do is we will create one more program, that is test process.sh, and in this we are going to write watch command is basically used to run any command in to execute any command and watch it output after any period of time. Like here I want that it should run after every 2 seconds, and it should give me the output of program psox okay sorry I need psox to be run, and then I want t.sh, and then I don't need t.sh, sorry, grep v, then grep. So what this program is doing is it is just running this psox, then the output of psox is being fed to grep, and grep is grepping for t.sh, and finally we are replacing the line for the process grep. So let me run this program, but before running this program I need to give execute permission to this program, and now I can run this program. So you can see that what it has done is it has run psox, and then it grepped for t.sh, and finally it gave me the output and it got out of this. But what I need here is I want it to run continuously and give me the output of this test process.sh after every 2 seconds. So for that what I will do is watch this program after every 2 seconds. So here we go. So what it is doing is it is running after every 2 seconds and it is giving me the output. So let me run this program here. So now you can see it has given me the output, and it is saying that there is a process t.sh which is running, and here I okay. So before starting this program, let me explain you some of the things what are PS output. So PS basically, what is a PS command? PS basically is a report, a snapshot of the current processes which are running your system, and here hyphen a is used for displaying all the processes, and then here we are using, note that PSOX is distinct from PSOX, and it will print all the processes owned by the user named X, as well as printing all processes that would be selected by the option A. So here, if the username X does not exist, this PS may interpret the command as PSOX and instead and print a warning, and the behavior is, so what it is going to do is it is going to display me all the list of processes which are running in my system. So now, as I have already executed PSOX, here you can see what does the field in this mean. The first field here means the user which has run this process. Now what is this number? This number is actually the process ID for this process which is running, and then comes the next field, that is the CPU which it is currently taking out of the total available CPU, and it is in percentage. So here we have 100% CPU, so what percent it is taking? It is taking 0.0. Then we have the percentage of memory it is taking, and then virtual size of that memory, resident size of that memory, and the TTY in which it is executing. So we have several TTYs in our system. TTY is basically a terminal, or the terminal in which it is executing, and then the state in which this represents the state in which the program is currently in, and then at what time this program got started, and how much time it has been executing. So here you can see it has been executing for 0.4 second, or I think it's in milliseconds. This I need to check. And then the command which has, what do you say, given birth to this process. So here this program or this process got started because of this command. So this was the command which started this process. So I hope I have explained all the fields in this PS output. Now here we have several what is the states of a process, but our main focus is to cover these process states which are very common, and we have here sleep or running, then zombie, and the daemon state of a process. So let me come back to this. So now we know the output of PS. What does PS output means? So now what we will do is we will just run our t.sh program, and after a few seconds you will see that this program is now running and is in S state, that is sleeping state. So this program has already executed the set of instruction in it, and there were two instructions written in it. First instruction was to print hello, and the second instruction was to sleep for 30 seconds. So right now my program is not doing anything, so it is in sleeping state, and the plus sign which we just saw after this represents that it is running in the foreground. Foreground means in the current we are able to see the output in the current screen. But suppose if we want to run a process in background, okay, suppose now I execute this program in background. So you can see now I am getting sleep, but there is no plus. So it means that this program is executing, but it is running in the background. So you can see that I have pressed Ctrl C and I have got a new terminal, but this program is again executing at the back end. So to bring it in the front, what I will do is I will bring it to the foreground, and now you can see again plus sign is visible. So this is how this is what the S and S plus means. So you have seen that we have created a program and gave it to our system to execute, and we have seen the sleeping state as of now. Now we want to see when the CPU got time to execute our program, it is called running state. Now we want to see the running state of a program. So again, what I will do is I will change the statements inside t.sh, and what I will do is I will give some instruction to this echo true. I will write some instruction in this program so that the CPU may execute it continuously. So what I have done is I have written inside this program, let me show you the content again. What I have done is I have written endless while loop inside this program, which is executing the command echo and then displaying true to me. So now it is continuously running. So now you can see that this program is running and is in the foreground. So the symbol R plus is there. Now what I will do is I will just kill this process and it is gone. So you can see that when the program is, so we have seen that R plus is running in foreground and R is simply running in background. And this also means that R plus also means that since it is running in foreground, it is interruptible. But this is uninterruptible. So we have seen the sleeping state, the running state. Now finally that there comes the terminating state that we cannot see because the program has already got executed and it is now out of our system, or we can say has been deleted from our system. Now there are two more states where a program may go, and that is zombie state and the daemon state. So what happens in Linux is that every process which is started has a parent process. What does it mean? It means that every process gets birth from another process. But how come the first process, so the first process which is started on the system is by kernel itself, and that program is called as init or systemd. Basic depending on your system, it may be systemd or a, so if you write ps3, so ps3 is basically a command which is used to display a tree of process. So right now if I see the tree of process, you can see that it is a tree out of which all the branches are coming out, and systemd is the first process which has given birth to all of these processes. But who is the parent of this process? The parent of this process is the kernel itself. So it executes the first systemd program, and further on systemd will what we can say give birth to all these programs in your system. So this is how the processes in the Linux gets started. So where were we? So whenever a process that is a child process gets killed or gets terminated, either it's get terminated or it gets killed. So what happens is it sends a signal to its parent process that it has got terminated, and now its entry from the process table can be deleted. But in some cases it may happen that the parent process itself has died before the child process. In that case, what will happen is this child process will become a zombie. And in case of, so in that state, what will happen is the entry of this process will remain in the process table, and the user has no uh, control over these zombie processes. So then then uh, then is the daemon process. So daemon process are those processes which are running in the background of our system, and in this case uh, in this case uh, I, in this case what is happening is they keep on running at the background of our system and are sleeping, and as so daemon processes basically the processes which are running at the background, and they are continuously listening for some uh, event from the user. So for this we need to understand some the process in a past day. So support so sorry so for example, if it's listening at port 80, then whenever any customer or any user hits the website and it requests any page at port 80, then the Apache processes are running in the background, and they are continuously listening on that port 80, and once this request from the user reaches the server, they will become active, and once the request is served, they will again go to the daemon or the D state. So this is the one of the example of daemon process in Linux. Then there are certain processes which are called as orphan process. So as the name says, orphan process are those process for which the parent process has got killed, and finally what will happen is that the root process, that is we saw that init process or the systemd process will take the control of these processes, and finally reap those processes when or we can say get the exit status from these child processes, and finally finish those from the process table. So what is the difference between the zombie and the orphan process? In case of orphan process, okay, so there is a minor difference, or we can say a thin line difference between orphan and zombie. So zombie has got killed or terminated, but its entry is there in process table. But in case of orphan process, its parent process PPID, parent process has got killed, but they have been given a new parent, that run it, and will now give their exit status to it. So this is the difference which is between the zombie and the orphan process. And by this definition, yes, orphan process can become a zombie process later if its entry from the process table does not get cleared later on. So that was the difference. And now we have seen several states in the process. Now we will see that what is process file system in Linux, so or the proc file system in Linux. So in Linux, kernel store information about all the processes in this file system, and this is also a virtual file system which is created on the fly whenever your system is started, and it will be deleted once your system gets shut down. So let's see what is there inside this. So now what we will do is we will just execute vi./t.s this process again, but again we will change some of the code here, and we will put a sleep of 500, and we will execute this program. And parallelly what we will do is we will just use socks. Parallelly we will grab the process ID of this program, and you can see that this process has a PID of, or a process ID of 34757. If we now go inside the proc file system, you can see that we have a folder with the same name here, and it is containing so much of information about it. But if you will actually check the size of these files, you will see that they are taking 0 space on your hard disk. So this proves that these are not stored on your hard disk, but they are residing on the memory itself. Now what does these files mean here? So these files are containing the information about your process. So let me show you the first thing. So you can see when I did the cat command line, you can see that this is the program which actually got, or this is the program which actually got executed when this process was created. So this file contains the information how this process got started. So the command which was executed is /bin/bash .t/t.sh. Now there are several other information which are contained here, like file descriptor. So you can see that in Linux every process has 3 file descriptors attached to it, and these are 0, 1, 2, and a separate file descriptor or another file descriptors can be there which can be attached to this file. So right now we will not dig deeper into this. Now moving on further, we can see that there are several other files as well, like which can be the okay. So let me show you one file. I think this is the file. Okay, so in this file you can see there are several fields, like what is the process ID for this process, then what is the state, what is the name of this process, and so on. So this is another file which is familiar to us, and Let me show you one more file. No. I was searching for a file where you can see. Yes, yeah. So this is the process. This is the file which contains the information about the process ID, and you can see there is one more ID, that is the parent PID. That is the process which gave birth to this process. So if I will see, or I will search for this process, you can easily see that this is another process. And if you check the CMD line, you can see it is the bash shell which has got executed first, and then on top of that bash shell we have executed this program that was ./t.sh. So it means that this bash interpreter which we ran is the parent, and then ./t.sh is the child which has gave birth to this process, that is t.sh. So I hope I made sense here. Now we have a, now we have the PCB, that is called as the process control block, which contains the information for every process that is running in your system, and it is included along with inside this proc file system. But the PCB is different from proc file system, and it's a, what do you say, data structure which contains the info about your process, and this also is stored in memory. So you can read more about PCB if you are interested, because this is all a theoretical portion. So I will conclude this lecture here. So I hope you would have liked this video. So please subscribe. Thank you.